This is number 15 on section 3.6, and we're told to find the minimum distance of f of x is equal to the square root of x, the minimum distance to the point 4, 0. Okay, so let me just draw a picture to illustrate what's going on here. We have this graph, and it's f of x is equal to the square root of x. Well, we know that at 0, we get a value of 0. At 1, the square root of 1 is 1, so this would be 1, this would be x, and this is y. At 2, the square root of 2 is about 1.3-ish. Okay, at 3, the square root of 3 is about 1.7-ish. At 4, the square root of 4 is 2. Okay, so this graph is looking like that. Okay. Now, what we're trying to do is figure out what's the shortest distance from this point 4, 0 to the graph, to the function. Well, it's not right here, because right here would be a little shorter. So it's somewhere in there. We need to figure out exactly what that distance d is. Okay? So, here's how we do it. We know that the distance formula is equal to the square root of x minus okay, in order to get 2 points, because the distance formula requires 2 points, it's going to be x2 minus x1 quantity squared plus y2 minus y1 quantity squared. In order to use the distance formula, we need 2 points. So the name of this point right here is going to be x. We don't know what the x value is, but it's going to be some distance x. From here to here, some distance x. And then the y value is going to be the square root of x. So again, the x value is some distance. We don't know what it is. It's the x value. And the y value just follows the function, square root of x. So we'll use that point, and then this point right here, which is 0, 4, and plug those values into the distance formula. So x2 would be, excuse me, not 0, 4, this would be 4, 0. Okay, so it would be x minus 4 quantity squared plus the square root of x minus 0 quantity squared, and then the square root of all that. Simplifying that, we get that this is x, we'll say, I'm just going to FOIL this out, x squared minus 8x plus 16, and then this 0 is insignificant, so the square root of x squared is just x, so it's plus x. So then that's the square root of all that, and then that would be equal to x squared minus 7x plus 16 is equal to the distance. Okay, because the distance is smallest, because this distance d is smallest when the expression inside the radical is smallest, we only need to find the critical numbers of what's inside the radical. So again, let me say that again. Because this distance d is smallest when the expression inside the radical is the smallest, we only need to find the critical numbers of what's inside. So let's take that what's inside there, and we'll say that that's f of x. F of x is equal to, well, maybe I should call it something else because that's f of x. So I'm going to call it g of x is equal to x squared minus 7x plus 16. A reason why it's smallest there is because it's smallest when the number inside of here is smallest, because if this is 0 inside here, then the distance is 0. If it's 4 inside of here, then the distance is the square root of 4, which is 2. If the distance, if the whatever's in here is 144, then the distance is 12. So the smaller this number is, the smaller the distance is. So let's find the critical numbers of this guy right here. And then we get that by finding the derivative. And then setting the derivative equal to 0. So the derivative is 2x minus 7. And then we're going to set that derivative equal to 0. So g prime of x is equal to 0. So we get that 2x minus 7 equals 0. So x is equal to 7 halves. So that's the critical number. And so finally, by the first derivative test, the point nearest to 4, 0 is the point 7 halves, comma, the square root of 7 halves. Okay, well, let's just get an estimate of what this is. So 7 halves, 7 over 2 is 3.5. So that's about 3.5. And then the square root of 3.5, let's just get that real quick. Square root of 3.5 is equal to 1.87, approximately. 1.87. Let's find that on our graph. Does that make sense? 3.5 is about right here. And then 1.87 is right there. And that would minimize the distance right there. Plugging this back into the formula for the distance formula, that will give us the smallest minimum distance.